The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, folks. Thank you for joining us for another episode of our SevenSignal Best Practices webinar series today. I see a few of you trickling in. Please let us know in the question and answer panel where you're tuning in from today. If you're working from home, if you're in the office, I'm actually in the Cleveland office today, and we are joined by Jim Vada, who is down south in Cincinnati. Jim, how are you today?
Good, Kelsey. Thanks for
Awesome.
having me. I'm actually a few miles north of Cincinnati in Oxford, Ohio, and I am working from home.
Awesome. Well, thank you. The weather we were talking about, we're getting that lake effect wind here. So gearing up for my first Cleveland winter. So, all on board for that. We have a few of you telling us where you're joining from. We have Paul working from home in Pennsylvania. Thank you so much. We have Jeff joining us again. Welcome back, Jeff, joining us from Galleon, working from home. We have Chris joining us from Pittsburgh. Let's see who else we have here. We have Carrie joining us from Chicago. Thank you, Carrie. All right, we'll keep dropping in the question and answer panel where you are joining us from today. Thank you so much. And we will go ahead and get started. So we are SevenSignal, the leader in wireless experience monitoring. And we'll go a little bit more into depth as to what that entails and how that aligns with our SevenSignal mission. So today we have a great topic. We have troubleshooting home Wi-Fi and wireless devices for remote employees with Mobileye. And we are joined, as I said, by Jim Vada, CWNE number 183, and our Director of Global Wi-Fi Solutions here today. Thank you, Jim, again for joining us today.
Good to be here. Thanks.
Awesome to have you back. So a lot to unpack here. My name is Kelsey Rizzuto. I am the marketing specialist for the SevenSignal team, and really looking forward to jumping into this topic, which seems to be a very relevant common thread for a lot of people on the line here today, as we're all working from home. So let's get started here. A few announcements just to begin. If you have joined us recently for our webinars, a lot of these will sound familiar. But just to recap, we do partner with CWNP for every single one of our webinars. So by watching these every week, you are eligible for CE credits. So if you're pursuing a certification, just shoot us an email, drop us a message, and we can get a certificate sent over to you shortly after. We also host a product tour every single Friday at 12 noon Eastern at that link listed there, go.sevensignal.com/tour. And I'll go ahead and drop that link in the chat panel later in this webinar so you can go ahead and register if you're interested. We also have some really exciting product updates that I'm going to go ahead and read off here. We recently are releasing Mobileye for iGel Linux in October, so looking forward to that. We also have added enhancements to Sapphire over-the-air mode, and we've announced that we are coming out with a portable Sapphire Eye sensor this month. A lot going on there, really excited for what's to come. So keep an eye out on our socials, on our website for all of our product updates moving forward. Moving on, we also post all of our archived webinars to our YouTube channel. SevenSignal, you can look us up. So go back and rewatch some of the insights and the topics that we've covered in the past. And we'll go ahead and post today's webinar shortly after the broadcast today on there as well. We are also very, very active on our Twitter account at SevenSignal, and we usually post our slides a couple hours after the broadcast as well. So if you're interested in accessing today's presentation, we will go ahead and post that there. And if you don't have a Twitter account or you're not active on there, no worries, just shoot us a message and we can email you those slides per request as well. Another reason to follow us on Twitter and keep an eye out on our Twitter page is we've been very, very active with offering SevenSignal merchandise to those who follow our account and who engage with our trivia questions. So I'm going to go ahead and read last week's lucky winners who should be receiving an email soon for being able to ship these prizes. But last week we had Carrie Forrington, Tom Matthews, and Peter Zoller. So congrats to you three. Thank you so much for joining us last week and engaging with our webinars. And for the rest of you on the line, go ahead and give us a follow and engage with today's trivia question that should be coming up shortly for a chance to win some swag. Before we move on, just one more announcement that we're really excited about. We have recently been featured in the Gartner 2020 Market Guide for Digital Experience Monitoring. SevenSignal has been recognized as a representative vendor for Mobileye, and we will go ahead and drop a link in the chat here as well, so you can have access to that and check it out. All right. So as we begin, just to give you a little background on SevenSignal, we were established in 2007 in Helsinki, Finland, and we're now located in Cleveland, Ohio. We've hit a lot of major milestones along the way. We are really proud of the 1 billion data points that we're analyzing daily, in addition to the 5 million devices we're monitoring daily. We have over 200 customers, over 30 partners, 14 patents, which just goes to show that the technology that you see from SevenSignal, you are only going to see from SevenSignal. Additionally, we are certified in over 40 countries, and we're GDPR compliant for our EU folks on the line here, which ultimately means that we take data and privacy very, very seriously. So as I said, SevenSignal, we specialize in wireless experience monitoring to enhance the digital experience, because we want you to be able to focus on what matters most, not connectivity issues. We aim to enhance that productivity as well. And how we do that is we are able to provide full visibility into the end user experience through an outside-in approach through our platforms of Mobileye and SapphireEye. We are also completely AP and device agnostic, which means that we're incredibly complementary to those great devices or those great networks that you already have installed right now. So what we're able to do is to identify those top 7 Wi-Fi problems when we gain full visibility into that network. No one has created that perfect access point, that perfect network, and usually these top 7 Wi-Fi problems need to be resolved quickly, such as congestion, coverage loss, co-channel and radio interference, roaming issues, etc. And how we're able to identify those critical problems is by running active and passive tests on the network, trying to detect things like throughput, packet loss, latency and jitter, and more, giving you that full visibility into what is occurring in your wireless network environment. So just to give you a background as to what makes SevenSignal so different with this, is if you look at a typical, enterprise LAN infrastructure, you've already got great tools, great technologies installed on the network, such as your Riverbed, Cisco, Aruba, Avneta, and SolarWinds, etc. But what SevenSignal does is we take it one step further, picking up where that leaves off and giving you full visibility into the end user experience. With Mobileye, we're able to be installed on ultimately any mobile device, such as your laptops, your mobile phones, Zebra scanners, workstation on wheels, and more. And Mobileye can be installed on any Mac OS, Linux, Windows, or Android device as well. In addition to that, we do have SapphireEye, which are the sensors installed up in the rafters, looking down on the network, giving you that service level quality and RF visibility. What we're also able to do is give you that external network visibility. Those great tools that you already have installed on the network, as we mentioned before, you're not really using when you're working from home, all of those things that were already on that enterprise LAN infrastructure. So what we're able to do is to give you that visibility into your home networks, whether you're working from a multi-tenant apartment, your house, a coffee shop. We can give you that insight and data into what's occurring in your network, giving you that reliability to keep you productive and moving forward with your workday. And as I said, work from home is here to stay. A lot of you are working from home who are on the line today. And for example, 76% of remote workers use video conferencing daily as a part of their work. So with Mobileye, we're able to get that insight and that perspective as to what's occurring in your external home network so that you're able to stay connected and you're able to have a great digital experience no matter where you're tuning in and working from. Now, in regard to this, we've been doing a give back, which is Mobileye offer for 50 devices for 50 days. And we'll go ahead and drop this link here at the top, go.sevensignal.com/50 for 50, so you can go ahead and check it out. All right, so on with the show here. We're going to talk about our trivia question for today that Jim provided us with. And as I mentioned before, if you engage with our trivia question and answer correctly, you might be able to win some SevenSignal swag. So we're going to go ahead and launch this poll. All right, are you able to see this question here, Jim?
Yep.
All right, awesome. So go ahead and drop your answers in there. What is the Skype for Business minimum round trip latency required for voice communication?
Yeah, so not directly a Wi-Fi question, but certainly something that has implications on Wi-Fi, and certainly something that has a lot of implications for work from home troubleshooting.
All right, I see a few of you dropping in your answers there for this question. I'll give it just a few more seconds. All right, and let's see these results. How did we do, Jim?
Well, not very good, but it was a little bit tricky. So the correct answer is the round trip latency required is 100 milliseconds. The one-way latency required is 50 milliseconds. So I think everybody was thinking the same thing, but maybe a tricky question.
All right, great job, everyone. Thank you for that question, Jim. So what we're going to do here now is we're going to pass the controls over to Jim here, and he will go ahead and get started with today's presentation.
All right, sounds good. And there we go. Let me get some things out of the way. All right. Okay, so real quick, what we're dealing with, and first about me. I'm the Director of Global Wi-Fi Solutions here at SevenSignal. I'm a CWNE and a CCNP wireless. And as you can see, Cisco recently simplified the CCNP certifications, so they're much easier to understand. I'm also a wireless network engineer by trade, and there's my Twitter and blog you can follow me at, and my amateur radio call sign if you want to reach me on the ham bands. But today is all about work from home Wi-Fi troubleshooting, and just to talk about the problem that we're all very familiar with at this point. But of course, in the spring with the coronavirus pandemic, a lot of people got sent home to work on very short notice, and a lot of enterprises were caught by surprise. You know, for many enterprises, even if they do have work from home users, if they have network issues, the answer was, well, the network in the office works great. So, you know, things changed very quickly. And again, a lot of us were caught by surprise. And now we've got, you know, business critical users at home using enterprise applications on residential, you know, / consumer grade networks. And we've got to figure out how to make all this work, right? We need business continuity. This is going to be the status quo for some time. And, you know, the problem to overcome is that we don't have the same tooling like we would in the enterprise. So we don't have visibility, we don't have control, we don't have QoS. In a work from home network, it's a real, you know, sort of a black box. So, you know, what do those home Wi-Fi networks look like? Well, most people know that if you're not a network engineer, you're going to have pretty low cost consumer grade APs that lack the features and use low end components compared to what we do in the enterprise. the internet circuit's going to be best effort, right? There's no SLA on packet loss and jitter from your residential internet provider. There's probably no network design, right? Again, if you're not a network engineer, think about your aunt or your uncle that works in a totally different field. They go buy something at the store, they plug it in, they can load a web page, they're done. That's good enough. And to be fair, that works. But when it comes to meeting the requirements of our applications on the enterprise, Skype for Business being an example, there's no guarantee that's going to work. And that kind of comes into that last bullet there. There's no QoS on those circuits, and probably on the internal LAN as well, QoS is a little bit, it's probably unconfigured and may not be working so well. On top of that, I'm going to pick on some vendors here. There's a lot of snake oil in consumer Wi-Fi, to be blunt, and there's a lot of stuff being sold that's causing more problems than it fixes. This is a spec sheet from Asus, from one of their high-end gaming routers, and they're not the only guilty party here, but this just gives us an example of, again, what we're dealing with for our enterprise applications, what kind of hardware they're passing through, and some of the features that are marketed as benefits but actually might cause problems. So let's go through a couple of these. So first, this is a router that has 3 radios in it. I don't know many homes that need 3 radios at least co-located in a single access point. So this is going to be using a lot of spectrum. You can bet that the 5 gig radios are 80 megahertz out of the box. We'll kind of breeze past the 10 gigabit part because, as we know, many businesses don't even require 10 gigabit connections to the entire business. Yet we need that kind of throughput at home. I don't think so. It's kind of neat, actually, that this AP supports the DFS channels. At the same time, for us Wi-Fi engineers that are on the call here, on the webinar, we can deal with DFS. We know what the rules are and know what to expect. Would your aunt or uncle understand what was happening if their AP was trying to use a DFS channel that was blocked by an incumbent, a weather radar, something else like that? It was changing channels all the time. What's the chances that consumer grade AP will handle DFS hits intelligently? WT-Fast, some kind of weird gaming VPN, again, just adding unnecessary complexity here. Adaptive QoS, this is that layer 7 QoS stuff where we're trying to identify applications based on the packets that we see come across the device and then apply QoS. That's really hard to do. We try to do that in the enterprise, and it's very, very difficult to get right. So another thing that might cause trouble. Mesh, with 3 radios and super wide channels, spectrum hog, our neighbors are not going to be happy about that. And then probably the scariest thing here in my mind is this AI protection feature, which does attempts to do the same layer 7 application signature based discovery, but then it takes it to the next step and allows you to block by applications. And all that sounds great, but it's so hard to get that right. And we do that in the enterprise too with very, very expensive content filtering devices. They're buggy. They block things regularly that we don't want to block because they were misidentified. You've got a team of high-skilled network engineers and security engineers and vendor support to make sure that is working okay. At home, again, we've got super low-cost hardware and software, and you know, an end user that is unsophisticated that has to deal with that. So you know, a lot of issues that could trip up our traffic, you know, not to mention, we talked about what Wi-Fi design at home can look like. You know, here is a Pinterest board where they're showing off all the ways you can hide away, you know, the ugly Wi-Fi router. You know, a lot of these devices are not aesthetically pleasing, depending on your taste, I suppose. But so people are looking for ways to get it out of their line of sight. They, you know, stuff it in a desk drawer, behind the TV, in a cabinet, you know, anywhere but where it should be for the best Wi-Fi performance, which is centrally located and out in the open. So a little bit of, you know, one thing that's better these days is some of the newer mesh APs are really, they've paid careful, you know, design attention to the aesthetics of them to try and encourage people to put them out in the open. So I think that's a good thing. So what do we do? You know, without any tooling, it's a bit like calling your cable company and going through their support script, which is incredibly frustrating for end users and the engineers, right? You say things like, well, can you move the router closer? And they might move it, but is it close enough? What's the actual signal strength? What's our data rate? We don't know. You know, unplug it and plug it back in. They all love to hear that. You know, asking an end user how fast their internet connection is, maybe they know, but they probably will just give you the downloads side of it. And residential connections are very often asymmetrical, where the upload side is much slower. Then you can sort of, you know, you can try to walk an end user through running some commands, say a ping command, to see if they can get out to the internet and look at the latency. But again, it's really frustrating. You're kind of dictating what they should type and asking them to read the output of, you know, a bunch of text that is just meaningless jargon to them. So again, very, very frustrating, and for both ends. For our end, on the network engineer side, you know, we just need more data, and we want to be able to get it without being disruptive. So, you know, another solution for home Wi-Fi is to not use Wi-Fi. I'm not using Wi-Fi right now on this webinar. It's too important. And the reason is, you know, Wi-Fi uses unlicensed spectrum. Doesn't matter what generation of AP I have. I could have 11AX APs. I could have 11B APs. They all use spectrum that is subject to interference from other users. So don't use it. Use Ethernet. Use you know, run twisted pair Ethernet up to your desk. Okay, well, unless you're building a new house, a lot of people are not interested in running cable. So there are two solutions using existing cabling in the home that I've had pretty good experience with. The more popular one is power line Ethernet. And so what that does is actually uses the electrical lines in the home to create an Ethernet network with. And you know, it's a little bit iffy. I would say keep your receipts if you buy some of the stuff, because its performance is very dependent on you know, the quality of the electrical infrastructure in the home. If it goes across a circuit breaker, sometimes that can be a problem. You know, electrical cabling isn't done for you know, to meet Ethernet specs. So, but you can still get 200 to 300 megabits per second in the best case with that. And I've had good luck with it too. The other option for using existing cabling is a technology called MoCA. MoCA 2.0, and now 2.5 is the latest revision. This actually uses coaxial cables in the home that were installed for cable TV or satellite TV. If you've got RG6 in your house, this will work really well. That's what I'm using actually right now. for this webinar. I've got a Mocha 2.0 adapter in my office, and the other adapter is down in the rack in my basement, and I easily can get a gigabit per second through that, and it's very, very reliable. So something to consider if you're doing a lot of really important work, and you know, you can consider alternatives to Wi-Fi. So you know, still most of your workforce, of course, will be using Wi-Fi, and I use Wi-Fi too. On a nice day, I'd love to be able to work on the back porch and you know, get some sunshine. So what we can do with Mobileye is help solve that visibility side of the problem. So with that Mobileye agent that can run on your enterprise endpoints, you can see all the Wi-Fi metrics streaming from that machine, and run tests that tell you throughput, and really give you actionable insights into problems on work from home networks. So with that, I want to dive into a demo. Let me switch my screen. There we go. All right, right side of tabs, I got it. So this is Mobileye, and this is one of our own work from home users here at SevenSignal. He's running this agent on his Windows laptop. It runs in the background, and it uploads data here to the web where we can look at it and do analysis on it. And the first thing I want to look at, just looking at the single machine, is, you know, the network for this period of time is hashtag #MomoGoBoom. So no, that is not one of our corporate SSIDs. He must be working from home. And he's a big cat guy, so I believe if you search Instagram, you'll find all sorts of cat photos from him there. And he just wants to be loud and proud about it with his SSID, so good for him. But you can see there's a number of problems we've discovered here. Maybe one of the most interesting ones to see is that we've actually seen some roaming issues here. If I dive in and look at some of these issues, you know, we've got a roaming issue here. We've automatically discovered it. And what we saw was his signal strength on his connected AP was terrible, -84 dBm. But he had another AP at -68 dBm. So roaming, you know, it's not something we often think about for work from home users, but mesh networks are very, very popular today. And for that to work in a multi-AP environment, you need a device that roams well. So here we have some roaming issues. You know, what often can be a issue there is the adapter and driver. So Mobileye shows us the wireless, the specific wireless adapter running on the machine and the driver version. So I can go and look at the release notes for that, look at release notes of newer driver versions, and see if there's a fix that might help us out. Of course, like we talked about, the more common thing is coverage issues. Very easy to see his signal strength over time and see where he had low, low signal strength, which could be, you know, coverage issues. We also generate problems for those as well. And you know, the nice thing is this is the real data streaming from this machine. So I can go back in time and say, you know, when he had an issue, when his Zoom call broke up, or, you know, he logged a support ticket 3 days ago that finally got escalated to the network team to look at, I've got the data from that specific point in time that I can jump into and see what was going on. So another thing to look at, you know, we've just looked at passive data so far, is co-channel interference. So I can see all the scan results, which is really great. All the network's Wi-Fi scan results from his machine over time. So I can see if he is using channels at certain points in time that his neighbors are using, and if they're overlapping. And if he's in the 5 gigahertz band, which we'd usually prefer, or if he's in the 2.4 gigahertz band, which can often be kind of an ugly mess in residential situations. But his networks are all good. He's been able to avoid his neighboring networks pretty well. And then the other thing to look at are congestion issues. So I can look at the raw throughput numbers to see what his throughput is. I can also see channel utilization from the APs he's connected to, which is really cool because we can grab that right out of the beacon frame, and that'll tell us, you know, do we have an issue with the internet connection, right? If we have nice clean Wi-Fi data, but our throughput's low, we've probably got an issue with the internet connection. Or if we have, you know, poor throughput and channel utilization is high, maybe we're in 2.4 gigahertz, you know, that's probably a Wi-Fi issue. And again, that's a problem type that we automatically identify. Like you see here, we've got throughput, terrible throughput. If I had less than a mega throughput right now, this webinar would be off the rails. But you can see signal strength is great. Data rate is as high as it'll go for this machine on an 11AC network. And the channel utilization is just 1%. So very, very nice Wi-Fi statistics at the time, and just low throughput, probably from that, you know, residential internet connection that's causing issues. So the other thing we can do in our active tests is point these tests at custom endpoints. So I mentioned Skype for Business at the beginning. Just wanted to show you real quick that here is a gateway for Skype for Business that we're just pinging, and we can measure the round trip latency to make sure we're within that 100 millisecond round trip time that Skype for Business requires. We can also, you know, ping internal things. So if they're connected to a VPN, which a lot of remote workers are, and we want to make sure our applications have the right, you know, are within our latency SLAs, we can do that. So there's a lot here just from a single machine for troubleshooting we can do to get to the bottom of work from home performance issues. We can also run some reports like this one, which help us just proactively identify who's having issues. So here we're looking at the same Wi-Fi issues that we saw on the device page, but we've got them all grouped together by access point. And you can see I've got this sorted by coverage to see where are the most coverage issues. And it's this particular AP. So whoever's got that has had the most coverage issues. And if we drill into these, we can see you know, what the client was, what the signal strength was, when it occurred, to help us identify where, you know, this problem a little bit better. So yeah, here I can see it was Paul's MacBook Pro. Looks like a work from home network. These are usually easy to pick out. and just low signal strength. So we can look at our other problems this way as well, including congestion, which is helpful for identifying users that might have you know, poor internet circuits. One of the other features regarding internet circuits that we have now is we'll show you the external IP address of the public IP address that the user is behind. And that's useful because you can jump right into a whois lookup with Aaron and see who their service provider is. In this case, it's AT&T. So you can you know, you can even tell the end user, your Wi-Fi looks fine, their internet's really slow, you need to call AT&T and either get an upgrade or see what they can do to help you out. A couple other things I want to mention. We looked at this. Here's our configuration. It's very flexible. What's nice is that I can alter all our thresholds here to tailor them to the requirements that you have in your enterprise. So whatever signal strength requirement you have, whatever throughput requirement you have, based on the applications you support, your ping round trip time, you know, I might bump this down if I was supporting voice applications, and all these tests I can alter as well to add custom endpoints and only run on certain SSIDs. It's very, very flexible. All right, so with that, let me jump back into the slides. And okay, just a couple kind of wrap up points. Mobileye gives you visibility into work from home networks. We show you the problems, we show you the overall performance. You can see if there are client induced problems like that adapter driver. You can get a good feel for the Wi-Fi performance and the internet circuit performance as well. And you can even tailor it to measure and test, your own enterprise applications that are so key. And again, work from home, remote work is here to stay. We've seen a lot of announcements from big companies that just have said, we're going to do this from here on out. Our employees like it. Productivity is good. So this is the status quo going forward. And again, your end users they're not IT folks, most of them, and they need help, and you need data to be able to help them. So that's where Mobileye comes in. All right, Kelsey, I think with that we can go into the Q&A.
All right, thank you, Jim. I see a few of you have dropped in a couple of questions here. We'll get to those in just a second. For anyone else that has anything they'd like to ask Jim, just go ahead and drop it in the questions panel. Before we jump into that, Mike said that you should get bigger earphones.
Well, actually, these are perfectly sized to my ears.
Got the full setup over there.
Yes.
Perfect. All right, awesome. All right, thank you, Mike, for that. Let's jump into a couple of questions here. We have a question from Peter, and he would like to know if Mobileye currently gives you visibility for work from home people using Ethernet cable, Powerline, or Mocha.
Yeah, it's currently just for Wi-Fi. So when Wi-Fi is the primary connection, that's when you'll get measurements in Mobileye.
Perfect. All right, thank you, Peter. We have a question from Alan, and he wants to know, does the app identify devices connected to the home Wi-Fi?
No, it really just focuses on the performance from the device it's running on. So the performance between that device and the access point, and then out to the internet from there. One of the things we do though is grab the station count, the client count from the access point. So you don't know who the other users are on the AP, but hey, there's 25 users on this AP while I'm using it, and that might be the source of an issue too. So that's a really nice feature we've got.
All right, thank you very much. Our next question here is from Jared, and he would like to know, is a client installed on a user's computer to monitor wireless? How does it monitor their wireless?
Yes, that's exactly what Mobileye does. It's a client that runs in the background on your enterprise endpoints, and it just collects all the wireless data it can from that machine. So it's grabbing the signal strength, the connected AP, the Wi-Fi scan results. It runs a ping and throughput tests and a lot more, and then it silently uploads that in the background where you can use it to analyze their performance.
All right, thank you very much, Jared. Our next question here is from Dan, and he would like to know, does the app show QoS classing made from applications?
It does not. We're not doing QoS visibility, but that is something I have a particular interest in. So we'll see about that.
All right, let's see here. Thank you for that, Dan. We'll keep dropping questions in here. All right, here we have a question from Jan. They would like to know, what do you tell the user when it's a Wi-Fi issue due to a very dense residential environment, when 2.4 is crowded on 3 and 4 channel plans and 5 gigahertz is all on overlapping 80 megahertz?
Yeah, good question, Jan. And I have certainly lived in some apartment buildings where that was the case. Well, so the first thing to do is, if you can, disable 2.4 gigahertz and don't use it. It just doesn't work in high density networks. And then when you're going to 5 gigahertz and you see it's crowded, everybody's got 80 megahertz channels, make sure that what you're putting that AP's channel, that radio on a channel where you're overlapping the primary 20 megahertz of the channel you're using with the other primaries of the APs out there. So, you know, in this case, co-channel interference is unavoidable. So look for the channels with the fewest neighboring APs on them, and make sure your primary channel overlaps with their primary channels, and then your secondaries will obviously overlap too. The reason you don't want to overlap primary and secondary, and this is something Devin Aiken has talked about a lot, and he did in one of our webinars previously, so look that up, is that clear channel assessment is really poor in the secondary channel. So if you have a neighbor on there with primary secondary channel overlapping, if you have a neighbor that's transmitting, they will just blast away and cause a lot of collisions on your primary channel. So make sure those primaries overlap, and look up that webinar from Devin. It was really good.
All right, thank you. We have another question from Germond. If someone has a small Wi-Fi support consultant firm and supports other by demand, could he get Mobileye installed on their devices and do the testing for a period of time and then remove it? Is it easy to configure the test platform for short-term testing?
Yeah, great question, Germond, and thanks for joining us. Yes, so we do support an MSP sort of topology where you have sort of a parent organization that has control over sub-organizations, which could be all your customers. And we also have a feature that allows the software to uninstall at a preset time. So if they're not machines you own, you know, if they're BYOD machines or it's a temporary engagement with a customer, you can, you know, run Mobileye and set it to uninstall itself after 3 weeks or something like that. So you can reuse those licenses elsewhere, and then, you know, have your hands clean from working with that customer. So we do support that use case.
All right, and let's see here. We have a question from Alan, and he would like to know if the data is saved on the user's laptop or server.
The data is not saved on the endpoints. It's saved in our cloud. The one sort of temporary exception is if their internet connectivity is interrupted. In that case, we'll cache all that data locally until we have connectivity again, and then upload it and purge it from the local machine.
All right, thank you very much, Alan. And I believe that was the last question that we have time for today. Thank you, Jim, for answering those. Thank you all for joining us today and taking some time out of your afternoon to really dive into this topic. We thank you again and hope to see you next week at our next webinar. So thank you all very much. Thanks, Jim.
Thanks, everybody.
Have a great day.